The focus of the rest of the notes and the videos is on covalent compounds. That's because there's a little bit more to the way that we draw them, the way that we explain them, the way that we think about their bonding, and how they look. All ionic compounds have certain similarities in terms of their structures, their properties, and the bonds, the big difference being size and charge. All metals have some similarities, the difference being how strong the attraction is, whether it's pure sample or an alloy. With covalent compounds, we've got a lot more possibilities of how we share our electrons and the properties that result of that. The main skill that everything builds on is the ability to draw a Lewis structure. So this is probably a skill you've used before and may go back to a biology class or an ICP or even a middle school science class. The Lewis structure, sometimes called the Lewis dot diagram, is where we're showing valence electrons either in a bond, so a line, or as a set of dots. That can show us single bonds in which we are sharing 2 electrons, a double bond in which we're sharing 4 electrons, and to refresh a phrase from earlier, these single, double, and triple is also referred to as the bond order. And then a triple bond where we share not just 3 electrons, but 3 pairs of electrons for a total of 6. Most of the time, we represent the bond as a line or 2 lines or 3 lines, but you can show them, and you will see sometimes on the AP exam, them just as depicted as dots between 2 atoms. So anytime we have a line or dots between atoms, we would assume that those are shared. Dots that are on the outside of an atom or not between them, those are our lone pairs. When we are drawing Lewis structures, these are the 5 steps that we would use. It is important to get really good at this, to practice and repeat it, rather than just guessing whether something should have single, double, or triple bonds, whether not guessing whether it should have lone pairs. If you really commit to this process, then you're always going to get them correct. When we do that, we account for the number of electrons, only thinking about covalent, the valence electrons, counting them up based upon the columns, adding them up for the whole molecule. When we have a polyatomic ion, we either put in extras when the electrons, when there's a negative charge, or remove 1 or more electrons for a positive charge. And when that happens, we should then depict our structure inside square brackets, showing the charge up in the corner. That's showing how many extra or how many fewer electrons we have in our structure. We then go through the process. We connect everything, starting with single bonds. Most of the time, you are just going to connect all of the elements to one thing in the middle. If it's a more complex structure, they might give you the skeletal structure, or they might expect certain small pieces in terms of like how a carbon could attach to an oxygen, something you have experience with. After we've connected everything, we fill the octets of all of the outer elements with 6 electrons. Remember, everything wants to fill with 8, with very few exceptions. Hydrogen is an important one. It never will have any dots because a single bond, and only a single bond, fills its energy levels. Never double bond hydrogen, never have any dots on hydrogen. Once you've done that, you may have used all of the electrons you've added up or may not. If you have extra electrons, those are the ones that would go into the central atom. If there are not extra electrons, then you just need to make sure, does everything have the 8 that it needs? If not, you need to move electrons making double or triple bonds, but if so, you're good to go. And the only way to do this is practice, and you'll see almost every problem after this has you drawing a Lewis structure first, then answering the next question. Whether we're looking at shape, polarity, hybridization, formal charge, we have to start with the correct Lewis structure. So practicing these rules and following them until they become automatic is super important. And when we've done that, the other thing is that we are almost always talking about a small number, 4 to 5, 8, sometimes a little bit more in large macromolecules, but a small amount of atoms, and we see that down here, bonded together. We don't have a repeating crystal like in ionic of cations and anions. We don't have a large network of atoms like in metallic compounds. That is what's very important and what changes the properties of these covalent